Hello, good evening everyone. Today I am going to explain about deadlock reduction and recovery. What is a deadlock? A deadlock is a situation where processes are unable to proceed because each is waiting for resources held by each other. In such a case, the system gets stuck and the wrong process can continue. To avoid this, we use Blanker's algorithm, which is a deadlock avoidance algorithm. It checks whether the system is in a safe state before allocating resources. A safe state means all processes can complete without causing deadlock. In this program, I implemented Blanker's algorithm using the C programming language. So this is the code I have written to both check deadlock and avoid deadlock. So in deadlock, there are three components. First one is need resource and maximum resource and allocation resource. So we can find the need matrix using the formula need equal to max minus allocation. Need equal to max minus allocation. The execution starts from the main function. All inputs are read and stored in matrices. So it's the main function. The user input is entered and stored in n and m variables. Then the user is asked to enter the allocation matrix. So the allocation matrix is the number of resources allocated to the process. Then the user will enter the maximum matrix required for the process. Then the user will enter the maximum available resources. So from here we have to calculate whether the system is in safe space or not. So this is the banker's algorithm logic that I have typed here. The program I initialize a work array with available resource and finish array to track completed process. The program checks each process in a loop. If the need of the process is less or equal to available resource, the process is allowed to execute. So here is the code. After execution, its allocated resources are added back to available. The process is then marked as finished. This process continues until all processes are completed or no further process can proceed. If all processes are finished successfully, the system is in safe state. Otherwise, it is in a unsafe state. The program also generates the safe sequence of execution also. The output displays whether the system is safe or unsafe and prints the safe sequence. Let me execute this program. So here we have to type the number of processes. So let me type number of resources we are going to use also we have to type. So now we have to enter the allocation matrix. Two, three, four, five. So now we have to enter the maximum matrix. I think but the maximum resources needed for this process to execute. So now we have to enter the number of resources available. So let's say 3, 4, 6, 7, 8. Let's say 5, 4, 6, 7. So here we can see that this is the system is in safe state if we execute the process in this sequence. First we have to execute process 1, then process 2, then process 3, then process 4. So this is the safe sequence that can be executed to avoid deadlock. Thank you.